After decades of research and billions of dollars spent in clinical trials, we still have a problem with cancer drug delivery. We still give patients chemotherapy, which is so nonspecific that even though it kills the cancer cells, it kind of kills the rest of your body too. And yes, we have developed more selective drugs, but it's still a challenge to get them into the tumor. And they end up accumulating in the other organs as well, or passing through your urine, which is a total waste. And fields like mine have emerged where we try to encapsulate these drugs to protect them as they travel through the body. But these modifications cause problems that we make more modifications to fix. So what I'm really trying to say is we need a better drug delivery system. And I propose, rather than using solely human design, why not use nature's? Immune cells are these versatile vehicles that travel throughout our body, patrolling for signs of disease, and arriving at a wound mere minutes after injury. So I ask you guys, if immune cells are already traveling to places of injury or disease in our bodies, why not add an extra passenger? Why not use immune cells to deliver drugs to cure some of our biggest problems and disease? I am a biomedical engineer, and I want to tell you guys a story about how I use immune cells to target one of the largest problems in cancer. Did you know that over 90% of cancer deaths can be attributed to its spread? And so if we can stop these cancer cells from going from the primary tumor to a distant site, we can stop cancer right in its tracks and give people more of their lives back. To do this special mission, we decided to deliver a nanoparticle made of lipids, which are the same materials that compose your cell membrane. And we've added two special molecules. One is called E-selectin, which acts as a glue that binds the nanoparticle to the immune cell. And the second one is called TRAIL. TRAIL is a therapeutic drug that kills cancer cells but not normal cells. Now, when you put both of these together, you have a mean killing machine on wheels. To test this, we ran an experiment in a mouse. So what we did was we injected the nanoparticles, and they bound almost immediately to the immune cells in the bloodstream. And then we injected the cancer cells to mimic the process through which cancer cells spread throughout our bodies. And we found something very exciting. We found that in our treated group, over 75% of the cancer cells we initially injected were dead or dying, in comparison to only around 25%. So just imagine, these fewer amount of cells were available to actually be able to spread to a different part of the body. And this was only after 2 hours of treatment. Our results were amazing, and we had some pretty interesting press. My favorite title was actually, "Sticky Balls May Stop the Spread of Cancer." Now, I can't tell you just how smug my male colleagues were knowing that their sticky balls might one day cure cancer. But I can tell you they made some pretty exciting, pretty ballsy t-shirts. This was also my first experience talking to patients where they asked how soon our therapy would be available. And I keep these stories with me to remind me of the importance of the science, the scientists, and the patients. Now, our fast-acting results were pretty interesting, but we still had one lingering question. Can our sticky balls, our particles actually attached to the immune cells, actually stop the spread of cancer? So, we went to our animal model and we found three important parts. Our primary tumors were smaller in our treated animals, there were fewer cells in circulation, and there was little to no tumor burden in the distant organs. Now, this wasn't just a victory for us and our sticky balls. This was also a victory to me in drug delivery, and it represents a paradigm shift, a revolution. To go from just using drugs, just injecting them, and hoping they go to the right places in the body, to using immune cells as special delivery drivers in your body. For this example, we used two molecules, E-selectin and TRAIL. But really, the possibility of drugs you can use are endless. And I talked about cancer. But where disease goes, so do immune cells. So this could be used for any disease. Imagine using immune cells to deliver crucial wound healing agents after a spinal cord injury. Or using immune cells to deliver drugs past the blood-brain barrier to treat Parkinson's or Alzheimer's disease. These are the ideas that excite me about science the most. And from where I stand, I see so much promise and opportunity. Thank you.